Number 8. A bicycle tire is inflated to 55 pounds per square inch at 15 degrees Celsius. Right? So we have a pressure at a particular temperature. Assume that the volume of the tire does not change appreciably, right? It may change, but it's negligible once it is inflated, right? So all the air is stuck in there. A, if the tire and the air inside were heated to 30 degrees Celsius by road friction, does the pressure in the tire increase or decrease? Well, we know that it will increase, but explain your answer. The pressure increases as the temperature rises. Let's do it a little bit. At a fixed mass, right? Mass doesn't change. And constant volume. And I'm throwing in these other things, the fixed mass and the constant volume, because the question did as well. It says assume the volume of the tire does not change appreciably once it's inflated, right? We're at a constant volume, and we have a fixed mass. There's a set amount of gas inside this tire, right? Once it's inflated, it doesn't change, right? It doesn't change. And so I want to make sure that when I make this type of statement, the pressure increases as the temperature increases, that I am controlling mass and volume. These things aren't changing. Now, because the temperature has doubled, does the pressure double to 110 psi? Explain your answer. Well, pressure has to do with force. Okay? Pressure has to deal with force. The temperature is doubled. Temperature is doubled. Well, gosh, does that mean that the movement of the individual gas particles is doubled? Trick question. The temperature on the Celsius scale has doubled from 15 degrees to 30 degrees. But what is the Celsius scale designed to communicate information about? Water. Water is the basis of the Celsius scale. We're not talking about water necessarily here. We're talking about gas. We're talking about the kinetic molecular theory of gas. What temperature scale do we use to talk about the movement of gases? The Kelvin scale. And so 15 degrees Celsius is actually 288 Kelvin. This would be 303 Kelvin. Has the actual temperature doubled? No. And if pressure is caused by the force of impact on the walls of the tire, if we haven't doubled the force, we're not going to double the pressure. So the pressure does not double because the temperature did not double. But wait, it says it is doubled. It did not double on the Kelvin scale, which measures kinetic energy. You can think of it as a trick question. You can get mad at me. That's fine. But it's just an interesting aspect that I want you to be aware of. When we're talking about gases, we want to think about the Kelvin scale because we're going to get a much more consistent image of what's going on. And then C, what will the pressure be when the temperature has doubled, right? Express your answer in pounds per square inch. So what we've already kind of hinted at is that we're really only experiencing a 30 degree, that's not a 30 degree, a 30 Kelvin increase in temperature, okay? And so when we go to have this much of a change, right, there's a certain percentage, and it's not a doubling, right? We're not having a 100% increase. So what percent increase are we having? Well, you guys know how percentages work. 288 divided by 303 times 100%. Let's crunch some numbers here. 288 divided by 303, and then multiply by that 100%. We're having a 5% increase, right? A 5% increase. That's it. No, that's not right. Goodness gracious, what am I doing? Totally wrong. Talking about the increase. The increase is 15 Kelvin. 15 Kelvin. That's all. 15 Kelvin. Okay? 15 Kelvin. So I should go, what's 15 Kelvin over 288? Aha, that's a better one. Okay. So now we're getting a much smaller increase. We're getting a much smaller increase. So what I'm going to do is I'm going to take that 5% increase that we just saw, that 5% increase, and apply it to my 55 my 55 pounds per square inch. Okay, so 55 times. What am I doing here? Gosh darn it. All right, add that to my original, right, the 55. That 5 tells me to round that up. So we'll go 57.8 PSI. Okay. Oops, sorry, got a little off center here. Okay. Because this temperature on the Celsius scale, okay, yes, it seems like it's doubling, but when we're talking about the movement of molecules, we need to be talking about the Kelvin scale. And how is this change affecting the kelvins, right? Because the kelvins are associated with the kinetic molecular theory and things moving, right? So we see that there's only a change of 15 degrees. Gosh darn it, not 15 degrees. 15 kelvins, right? What percentage increase is that, right? What percentage increase is that? That's what we want to communicate here.